Okay, hello everyone, my name is Catharina and I'm from the University of Oldenburg, and I would like to speak in the next couple of minutes about lateralization patterns induced in movement imagination and movement execution and their differences, and we revealed these differences by using EEG-fMRI and EEG-fNIRS. But before speaking about differences, I would like to have a look at similarities. Movement imagination and movement execution actually share a lot of similarities. For instance, plenty of studies have shown using the mental chronometry paradigm that imagination and execution follow basically the same spatial temporal constraints as shown in the study from Personier et al. And also other studies using neuroimaging techniques have shown that movement imagination and movement execution basically reveal overlapping networks or overlapping activity in cortical areas. And exactly these similarities between movement imagination and movement execution lead to the fact that movement imagination has been suggested as a promising rehabilitation approach for patients suffering from stroke. And here we basically can see the cortical activation patterns of stroke participants and healthy adults doing attempted right-hand movement or actual right-hand movement. And we see that in stroke patients we basically have a very bilateral activity pattern, where in healthy controls we have a very unilateral activity pattern. We also see this look at the EEG signature. So here you can see the event-related desynchronization in the 8 to 30 Hz frequency range. And on the x-axis you see the time in seconds, on the y-axis the event-related desynchronization, or the relative power in percent. And the second gray shaded area basically indicates this 5-second movement imagination window. And this is a single case, a stroke patient we acquired in our lab. And this participant had a left hemispheric stroke, so the right hand was affected. And what would you expect is like stronger contralateral activity, here displayed in blue, and less ipsilateral activity is displayed in red. But as in this stroke patient, overactivation of the non-lesioned hemisphere, we basically see the reversed pattern. And the differences between the contra and ipsilateral side is always displayed in green. Ward and colleagues have shown that this overactivation of this non-lesioned hemisphere is basically related to bad recovery outcome in stroke patients, which is why many interventions have now focused on restoring the original stronger lateralized pattern. And this is also what we aim for. We basically train the stroke patients over 4 weeks, every second day, using mobile EEG at the patient's home, so basically in the living room. And here you can see in this plot down here, on the x-axis is sessions, so 14 in total, and on the y-axis again the relative power in percent. And every green bar basically represents the degree of lateralization. And we see that over the course of time, the pattern, basically the lateralization pattern, changed towards a stronger contralateral, so lesion pattern, compared to the contralesional, so ipsilateral activity pattern. We also acquired MRI measures before and after this intervention, and here we can see the functional MRI data. So we basically have also in functional MRI data an increased lateralization after the intervention compared to before the intervention. And on structural level, we basically see more similar white matter integrity of the cortical spinal tract after the intervention compared to before the intervention, both of which has been related to increased motor function, which we also could observe in this patient. In order to taken together, so this we basically see that the restoring lateralization pattern seems to be crucial for motor recovery after stroke. It seems to be the fact that movement imagination, as this imagination training, seems to facilitate this cortical reorganization, and movement imagination supported by neuro even more facilitating this. And speaking about neurofeedback, we have like several techniques which can be supported or which can be delivered neurofeedback. And it seems to be that EEG is very promising because mobile and cheap solutions exist which actually enable this long-term home use at the patient's home. However, EEG has also some disadvantages, as we have the inverse problem, and therefore we basically aim to validate the EEG-based signatures induced by movement imagination using simultaneous EEG-fMRI. So here we investigated 22 participants and we provided real-time EEG-based feedback inside the scanner. We used this one-dimensional cursor feedback, and the task was a left or right finger tapping task. And what we found is, consistent with the literature, a negative correlation between the amount of event-related desynchronization, so contralateral event-related desynchronization, and the amount of contralateral fMRI bolt activity. However, if we have a look at the lateralization, the pattern gets a bit more complex. We do not see a significant correlation, but what we could find is basically several subgroups of participants. And if we have a look at one participant of each of those subgroups, we see at the top a very standard participants, I would say. So we have a normal modulation of event-related desynchronization and also a lateralization of event-related desynchronization here. And we also have a lateralized MRI activity pattern. And we have some participants, which is illustrated in this one down here, so where we have no modulation in EEG activity and also no modulation in MRI activity. Some people would consider this participant as a BCI illiterate. And then, most interestingly, for me at least, there's the group of fins represented by this participant. They show a very strong modulation in EEG, but no lateralized EEG activity. But in MRI, they show a strong activity and strong lateralization. So basically, we had a dissociation or a partial dissociation between hemodynamic measures and EEG measures. And this basically points out that combined measures or multimodal imaging basically can yield additional information and validate results. And keeping this in mind, we basically in our next study combined EEG, but we combined EEG now with fNIRS, as fNIRS has the advantage that it does not corrupt the EEG signal with massive artifacts. And here we also did not focus on inter-individual differences, but we focused on age differences. So we had one group consisted of healthy younger adults and one group of healthy older adults. And we performed motor imagery with and without feedback and movement execution. We provided a two-dimensional feedback displaying the amount of contralativity and the amount of lateralization at the same time. If we have a look at the results, then we found that younger adults have stronger lateralized activity than older adults during movement imagination, but not during execution. So we basically found age-related differences in movement imagination, but not during execution. And this seems to be a fairly robust finding because we replicated this in our lab with a different population. So all the time participants were naive to BCI and naive to motor imagery. But what is actually with a second independent modality? So what is with the fNIRS activity? And here we can see the fNIRS activity. We basically see the deoxyhemoglobin signal. And again, on the x-axis, we see time in seconds. The gray shaded bar indicates, again, the 5 seconds movement imagination window. And on the y-axis, we see the deoxyhemoglobin concentration changes. And again, the contralateral activity is displayed in blue, and the ipsilateral activity is displayed in red. And this is basically analog to the EEG signal. So we see a stronger hemispheric lateralization in younger adults compared to older adults during imagination, but not during movement execution. But we also see something different in this data or in this plot. And if we have a look at the lateralization of the fNIRS results, then we basically see that we have, for execution, regardless of age, stronger lateralization compared to imagery, what we would probably also expect. But if we do the same in the EEG data, then we see that execution does not lead to a stronger lateralized activity pattern. And I found this very interesting, and this basically leads me to reanalyze the EEG-fMRI and the EEG-fNIRS data, which are both from this independent sample. So we basically looked at the younger adults only and reanalyzed this data with respect to the lateralization in movement imagination and execution. And here we can see interaction. So on the x-axis we see contralateral activity, ipsilateral activity, and on the y-axis the fMRI bolt activity. So basically the slope indicates the lateral, is an indicator of the lateralization. So we see that for fMRI we have a stronger lateralization in execution compared to imagery. If we have a look at the fNIRS measures, we see a much similar pattern. So we have stronger lateralization in execution compared to imagination. And a different pattern emerged when we have a look at the EEG data. So here we see more or less stronger lateralization during movement imagination compared to execution. And this basically says that we cannot easily transfer lateralization patterns assessed in one modality to another modality. This also says that we have a complex relationship on the one hand between execution and imagination, and on the other hand between electrophysiological and hemodynamic signals. And why we actually have this dissociation, we at the present can just speculate. It might be due to the temporal high resolution of which provides us with several signatures, like slow cortical potentials, event-related desynchronization, or beta rebound, where in the hemodynamic we often have like one signature, and how much the contribution of each electrophysiological signature towards a hemodynamic signature is, I think we have to find out in the future. And I think this is one example of how BCI research can guide fundamental research, which could result in better or increased BCI or neurofeedback performance in future. With this, I would like to thank the neuropsychology lab headed by Stefan Debener from the University of Oldenburg. I would like to thank the NSF for the student travel and the BCI Society for organizing this meeting, and you for your attention. I'm happy to answer any questions right now or today in the poster from 8:30.
Wow. Thank you for all this very valuable